In this video, we are going to learn about simplifying trig identities. So our trigonometric identities, we have learned several. Our basic trig identities are sine, cosine, tangent, cosecant, secant, and cotangent that you began learning in geometry and we have expounded upon this year. We also learned about Pythagorean identities, sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. The way that I keep the tangent squared and the cotangent squared separated is cotangent and cosecant pair together, C and C pair together. And then our even and odd identities, all functions, it doesn't affect them. It really does make them negative except for cosine and secant. I would highly suggest writing these identities down on a note card for quick reference so that you are successful throughout the remainder of this unit. Tips for simplifying identities. First, you want to look for ways to use the fundamental trig identities, which are the 6, sine, cosine, tangent, cosecant, secant, cotangent. If there's a square present, look for ways to use the Pythagorean identities, those 3 that have sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. You want to look for ways to factor. You want to write every single trig function in terms of sine and cosine. Combine like terms. If it's a fraction, you may have to use common denominators to do that. And use conjugates for fractions. So let's look at an example. We're going to simplify this trig identity. Tangent x times cosine of x. Well, the first thing that we want to do is we want to write everything in terms of sine and cosine. So that means that we want to rewrite tangent x because it's the only trig function present that's not in terms of sine or cosine. So tangent is sine x over cosine x, right? So now we need to bring down our cosine x. All trig functions are over, all numbers that are not written as a fraction, we understand are over 1. So now we can simplify. We could rewrite this as sine x cosine x over cosine x. Or we could recognize that we have a cosine on the top and the bottom, meaning that they divide out to 0. Either way, whether we do it in the first step or the second step, we realize that our cosines divide out, so we are left with sine x, which is as simple as this one goes. Let's look at another one. We're going to simplify secant x minus cosine x all over tangent x. The first thing we want to do is to rewrite these trig functions in terms of sine and cosine. So I'm going to write secant as 1 over cosine x minus cosine x all over sine x over cosine x. So I know that this function is really over 1. So let's multiply the top and bottom by cosine so that we can simplify this. So now we have 1 minus cosine squared x all over cosine x. And then I'm going to say times, and this fraction right here, because I'm dividing by a fraction, I'm multiplied, and then now I'm going to flip it. Cosine x over sine x. Now this is going to make my life a lot easier because I see a cosine x on the top and the bottom, so it divides out to 1. So now I have 1 minus cosine squared x over sine x. Now what I notice here is I notice that I have a squared function. So I want to try to use those Pythagorean identities. And the Pythagorean identity that involves cosine squared is sine squared plus cosine squared equals 1. So if I subtract cosine squared from both sides, then I get sine squared x equals 1 minus cosine squared x. Now looking at this, I see that this is exactly what I see in my problem, meaning I can replace my problem with sine squared x. So now I have sine squared x all over sine x. Just like if I had x squared over x, that would simplify to x. This also simplifies to simply sine x. So that is that identity simplified all the way. Let's do another one. Example 3, we're going to simplify sine squared x minus 1. Now I see a squared, so that tells me that I need to start looking at my Pythagorean identities. I know that sine squared x plus cosine squared x equals 1. So if I say cosine squared x equals 1 minus sine squared x, that almost looks like this identity. However, they're in opposite order. So how about I multiply this entire thing by negative 1? So now I have negative cosine squared x equals negative 1 plus sine squared x, which I know I can also write as sine squared x minus 1. So now I know that I can rewrite because this line matches this line, I can replace it with negative cosine squared x. And so that is my trig identity simplified. Well, I don't want to write it in green. I want to write it in black. So there is that one. All right, last one. We're going to simplify the trig identity 4 cosine squared plus cosine x minus 3. And what I notice is that I have a quadratic function happening here. Let's look if we rewrote this function as 4x squared plus x minus 3. Well, I would say 4 times 3 is 12. My factors are 1 and 12, 2 and 6, 3 and 4. I need 2 of these that subtract to give me 1. So I see that 4 minus 3 equals 1. Putting both over my ax, which is 4x, I get 1 over x and negative 3 over 4x. Now I know that this would factor to 4x minus 3 bottoms up and x plus 1. Now here's the thing. I can do this because only thing I did here is I said x equals cosine x. So now everywhere I see an x, I need to replace it with cosine x. So 4 cosine x minus 3 times cosine x plus 1. And there you just factored out this trigonometric function without even actually having to use the trig functions until the very end, which is what I would really like to do. So every single time when you see your trig function, substitute it with x. So that concludes this video on simplifying trig identities. Make sure you have your trig identities written down on a note card because it will make your life so much easier. All right. Good luck, guys.